So this is a demonstration to look at the different situations for the ambiguous case, which is when you're given two sides and a non-included angle. So we will draw a ray because we don't know how long this third side is, but this is my given angle. And for this first situation, we're going to assume that my given angle is acute. Okay. Here's the first given side, and I have little straws to show you. So they gave me this angle, they gave me this side, and then they gave me another side. So for SSA, the two sides have to touch, and this angle is not in between them. So I'm going to connect here, and then try to swing this until it closes off and makes a triangle with this ray. Okay. So if I connect here, I'm going to swing it and see if it'll touch. This particular segment that I picked out touches right in this one spot. So if I continue swinging it, it doesn't touch, but it does touch right in that one spot. Okay, now this particular length that I picked out creates what kind of triangle? A right triangle. So this side opposite the given angle ends up being just the height of a right triangle. Okay, and how many triangles did I create? Just the one. Now what happens if, so this is we can call this the altitude here. What happens if my opposite side is shorter than my height? It's too short. It's never going to reach. Okay? If your opposite side is shorter than the height of that right triangle, it's never going to touch. No matter which way it swings, it can never reach this. Okay? So this is the situation where you have 0 triangles if your opposite side is less than your height. Okay? Now, what do you think will happen if your opposite side is greater than your height? Longer than your height?
It'll make an obtuse.
Well, let's see. So if I start out here and I swing, it's going to hit once here. So that will create a triangle with the side-side angle that's given. But if I keep swinging it, it's actually going to hit that ray a second time. And it's going to create a different triangle that still has the same side-side angle. So both those triangles have the same given two sides and non-included angle, but what kind of triangle is this one? This triangle is obtuse, and what kind of triangle was this one? That one's acute. So it creates two triangles. If your opposite side is longer than your height, it's going to hit twice. But what if it is way longer? What if it's longer than this adjacent side? How many triangles do you think will it create?
1.
So it'll create this one way out here. But what's the problem here? When I swing it this way, it's not going to hit the ray again before it just closes up on that adjacent side. Okay? So if your opposite side is longer than your adjacent side, it just creates the one triangle. Because when it comes around here, there's no second triangle. What if it's equal to the adjacent side? How many triangles would that make?
1.
It would make that one, and when I swing it all the way over here, what happens? It just closes itself, and it's not going to hit again and make a triangle. So that if it's equal, it just makes one triangle. And specifically, what kind of triangle is that?
Equilateral.
No. You have two sides that are congruent. Isosceles. Okay. So here are the situations. If the opposite side is equal to the height, how many triangles do you have? 1. What if the opposite side is less than the height? None. What if the opposite side is, that's the adjacent side. What if the opposite side is longer than the height, but shorter than the adjacent? That's the one that makes 2. And then if it's longer than the adjacent, it makes 1. Okay. So does everybody kind of see where the 0, 1, and 2 triangles are coming from?
So there's 2 situations where it's one triangle.
Yes?
One situation where it's 2 triangles.
Yes.
And one situation where there's no triangle.
Correct. All right, so what we're going to do is we're going to summarize those in chart form. We're going to put it all in a chart in a second. I'll just give you a little glance as to what that's going to look like, but you don't need to write it yet. So this is kind of to summarize. All right. We said if the opposite equals the height, you have one triangle. If the opposite was shorter than the height, you have no triangles because it dangles and it doesn't reach. If your opposite was greater than or adjacent to, if your opposite side is greater than or equal to the adjacent side, it makes one triangle. And then the only situation that creates two is when your opposite side is longer than the height but shorter than the adjacent. Okay, like that situation. All right, the other thing that I'm just going to show you is that if your given angle is obtuse, this is how you would set up your initial triangle. So we put the ray on the bottom again. We put our given angle here, only this time it's obtuse. This is the first side that I'm given. Is adjacent. Okay. Now, what has to be true for me to even create one triangle? None of those are going to reach this ray. So I heard someone say what? The opposite side has to be longer than the adjacent side. And then you create one triangle. That's it. So if your opposite side is not longer, what's going to happen is it's going to either lay flat onto itself if it equals the adjacent, or if it's less than the adjacent, it won't even reach this ray at all. Okay? So the nice thing about the obtuse is there's only two situations. Either there is a triangle or there's not a triangle. You just have to see is the opposite side longer or not. Okay? What? Put the acute back up. Yes? Oh, I'm going to project it here. Okay, so now we're going to go to the back to the active inspire file and summarize this in chart form.